Assalamualaikum and a very good day to Miss Hidayah and everyone. Today we are going to present to you about the group project for QMT342. Before that, I would like to introduce our group members. Firstly, Nadia Syakirah binti Muhammad Zain. Next, myself, NOORAQILAH binti ABDUL. Next, ADILAH binti ZULRAHIM. Fourth, SHYAFIQA binti NAZREE. And lastly, SYUHADAH binti NASEB. Moving on to the first question, the lambda is 5 boats per hour and the mu is 10 boats per hour. A, the probability that no boats are in the system is 1 minus rho. The rho is lambda over mu. So 1 minus 5 over 10 is 0.5. B, the average number of boats will be waiting for service is lambda squared over mu times mu minus lambda. Insert the value and you will get 0.5 boats. Next, for question C, the average time a boat will spend waiting for service is lambda over mu times mu minus lambda. Then you will get 0.1 hour. For question D, the average time a boat will spend waiting for service is 1 over mu minus lambda and the answer is 0.2 hour. Next E, if I were the manager of Kuasa Fishing Marina, I will be satisfied with the service level of the system. It is because the average number of boats that will be waiting for a service is 0. The average time of waiting for a service does not reach an hour and the average time a boat will spend at the dock is less than an hour.
Next, I will continue with question 1F to J. For question F to I, the mu and lambda will be the same as question A to D, which is 10 for mu and 5 for lambda. But we will use the multi-channel queuing model formula since the dot will be 2. Thus, the S is equal to 2. First, we will find the rho using the formula. Then, we will get the rho equal to 0.25. For question F, to find the probability that the boat dot will be idle, we need to use the formula PO. Substitute the value of mu, lambda, S, N, and rho into the formula, then we will get the probability is equal to 0.6. For question G, to find the average number of boats that will be waiting for service, we need to use the formula of LQ. Substitute the value of rho, lambda, mu, S and PO to the formula. Then we will get the average number is equal to 0.0333 boat. For question H, to find the average time a boat will spend waiting for service, we need to use the formula of WQ. Substitute the value of LQ and lambda into the formula, then we will get the average time is equal to 0.0067 hour. Next, for question I, to find the average time a boat will spend at the dock, we need to use the formula of W. Substitute the value of LQ, lambda and mu to the formula, then we will get the average time is equal to 0.1067 hour. And lastly, for question J, my comment, based on the comparison, the service level that Kuasa will be providing with 2 docks will be better, since the average time a boat will spend waiting in queue and average time a boat will spend at the dock will be shorter. The queue will also be less packed, since the average number of boats that will be waiting in queue will also decreasing, but the probability that there will be no boat will be higher than 1 dock.
Next, I'm going to explain about question 2. Based on the given question, we get lambda is equal to 5 customer per hour, mu is equal to 1 customer per 7.5 minutes. Convert minutes into hour, we get mu is equal to 8 customer per hour. Question 2a, using single channel queuing model formula, we get the answer is equal to 0.375. Next, using the formula stated, question 2b is equal to 1.0417 customer, question 2c is equal to 0.2083 hours, and question 2d is equal to 0.625. For question 2e, based on the waiting line analysis, it shows that percentage that all customers should have to wait for technical support is equal to 62.5%. The average waiting time is equal to 12.4980 minutes. The analysis indicates that the Oscala's customer service guideline is not being met because the percentage that all customers should have to wait for technical support is more than 35% and the average waiting time is more than 2 minutes. We recommended to hire 1 more consultant in the system to satisfy the Oscala's customer service guideline. Next, for question 2f, the number of server is 2 consultants, so we are use multi-channel queuing model formula. Based on the new waiting line analysis, the effect of using an additional consultant have on customer service is the percentage of all customers should have to wait for technical support is decreasing from 62.50% to 31.25%, and the average waiting time a customer wait for a consultant also decreasing from 12.498 minutes to 0.81 minutes. 2 technical consultants enable Ocala to meet its service guidelines because the new percentage all customers should have to wait for technical support is no more than 35% and the new average customer waiting time is less than 2 minutes. Lastly, question 2G, given C as equal to 9 ringgit per hour and CWQ is 50 ringgit per hour, we calculate both cost of waiting lines using formula as stated in the slide. The cost of waiting line using 2 consultants is less than cost of waiting line using 1 consultant. Ocala software system should hire 2 consultants because the total cost of waiting line is cheaper.
So I will continue with question number 3. So this is the output from QM for Windows, which is the lambda equal to 8 and the mu equal to 4. So as we can see, the average time in the line is more than 5 minutes, which is 6.67 minutes. So the average waiting time in the queue does not achieve Marty's rule that has been set. So since it is not achieve Marty's rule, I would like to suggest that Marty needs to hire 1 more barber in order to satisfy the average waiting time in the queue that he already set. This is the output for second situation for question 3a, which is the lambda equal to 12 and the server cannot be equal to 3 because when the server is equal to 3, the arrival rate exceeds the service rate. As a result, the line will get longer, making it possible to service all of the arrival. So the Marty's barber need to hire extra barber. So the number of server is equal to 4. As we can see, the average time in the queue is 0.13 hour or 7.6 minutes. So this is not achieved multi-screw. So the multi-barbers need to hire one more barber, which is equal to 5. This is the output for second situation, which is the lambda equal to 12. And the server cannot be equal to 3. Because when the server is equal to 3, the arrival rate exceeds the service rate. As a result, the line will get longer, making it possible to service all of the arrival. So the multi barber need to hire extra barber. So the number of server is equal to 4. As we can see, the average time in the queue is 0.13 hour or 7.6 minutes. So this is not achieved multi-screw. So the multi barbers need to hire one more barber, which is equal to 5. So this is the output when the number of server is equal to 5, and we achieve the multi-screw which is not more than 5 minutes for average time in the queue, which is 3.35 minutes. So this is the result of total cost with lambda equal to 8, mu equal to 4, and the number of server equal to 3. The total cost of the system is 79 ringgit 33 cent, whereas the total cost of the waiting time is 49 ringgit 33 cent according to the outcome. So this is the output for first situation, but when the number of server is equal to 4. So the total cost of the system and the total cost of the waiting time is like that. The second situation, which is the lambda equal to 12 and the mu equal to 4, but the number of server equal to 4. So the total cost of waiting time and the total cost of the system is stated like that. And lastly, this is the output for second situation where the lambda equal to 12, but the number of servers is equal to 5. And the total cost of waiting time and the total cost of system is stated like that.
Moving on to question number 4. There are 3 alternatives. Let's go to the first alternative. It says a single channel operation in which one employee fills the order and takes the money from the customer. The average service time for this alternative is 2 minutes. We key in 24 for the lambda and 30 for the mu. And this is the output we got from QM for Windows. Output from previous and this slide, we can get the probability that no cars are in the system is 0.2. The average number of cars waiting for service is 3.2 cars. The average number of cars in the system is 4 cars. The average time a car waits for service is 0.13 hours, which equivalent to 8 minutes. The average time in the system is 0.17 hours, which equivalent to 10 minutes. The probability that an arriving car will have to wait for service is 0.8. For question G, we need to key in the server cost as much as 6 ringgit and 50 cent and waiting cost 25 ringgit. Then this is the output shown by QM for Windows. We can get that the total cost based on waiting in the queue is 86 ringgit 50 cent and the total cost based on the system is 106 and 50 cent. Moving on to second alternative. A single channel operation in which one employee fills the order while a second employee takes the money from the customer. The average service time for this alternative is 1.25 minutes. From the both outputs, we can get that the probability that no cars are in the system is 0.5. The average number of cars waiting for service is 0.5 cars. The average number of cars in the system is 1 car. The average time a car waits for service is 0.02 hours, equivalent to 1.25 minutes. The average time in the system is 0.04 hours, which equivalent to 2 minutes. The probability that an arriving car will have to wait for service is 0.5. For question G, we need to calculate the total cost based on waiting in the queue and the total cost based on the system, which are 90 ringgit and 31 ringgit and 50 cent. Moving on to third alternative. A 2-channel operation with 2 service windows and 2 employees. The employee stationed at each window fills the order and takes the money from customer arriving at the window. The average service time for this alternative is 2 minutes for each channel. And this is the output shown by QM for Windows when we key in the lambda 24 and the mu 30 and the number of servers is 2. Once we key in the input, we can get that the probability that no cars are in the system is 0.43. The average number of cars waiting for service is 0.15 cars. The average number of cars in the system is 0.95 cars. The average time a car waits for service is 0.01 hours, which equivalent to 0.38 minutes. The average time in the system is 0.04 hours, which equivalent to 2.38 minutes. The probability that an arriving car will have to wait for service is 0.4. Question G, we can conclude that the total cost based on waiting in the queue is 60 ringgit and 81 cent and the total cost based on the system is 36 ringgit and 81 cent. We also have the output for cost versus servers. As conclusion, based on the result that we get from the first alternative, second alternative, and third alternative, the lowest cost design for Matic's fast food business is second alternative. It is because the cost of time spent in the system is only 31 ringgit and 50 cent, as it's the lowest cost compared to the first alternative and third alternative. While the cost of time spent waiting in the queue, Matic should choose third alternative, which costs 60 ringgit and 81 cent, as it is the lowest cost compared to the first alternative and second alternative. That is all from us. Thank you.